Well, this makes me a little bit nervous because we've come to a point where I have to start painting this thing, and before I can do that, I have to cover this with this. Now, this isn't the first time I've done this kind of thing. About 10 years ago, I made a 1/9 scale B-17, and it was all covered with fiberglass and resin. It had a 138-inch wingspan, 4 gas engines, retractable landing gear, operating flaps, ailerons, rudder and elevator, as well as a smoke generator and operating bomb bay doors. The client was from North Carolina, and he liked the detail I put into the ship models I made, so he wanted me to do the same thing on his airplane. It was a long project and a lot of fun, but I don't think I want to do another one. He was extremely pleased with the final result and sent me a video of the airplane's maiden flight. So here it is. We get back to the Oceanic in 1 minute and 12 seconds. Well, that was fun to see again, but now back to work. Before I can put on the fiberglass and start painting, I have some details to work on the hull. I have to make the propeller, this bearing, the supports for the bearing, the propeller shafts, and the fairing that mates the shaft into the hull. According to the plans, the propeller should be 4-bladed and about 4 centimeters in diameter. I was fortunate that I was able to find something similar at Shapeways, so I had these 3D printed. I'm going to make the propeller shaft bearings out of wood, and I'll start by center drilling both sides of the bearing. Then I'll drill the holes halfway through so that they meet in the middle. By doing that, as well as spinning the workpiece in the chuck and having the bit stationary, we can make a very axial hole all the way through. Here I've pressed the propeller shaft onto the bearing, and I'm going to spin it in a drill while rubbing it against sandpaper in the disc sander. The disc sander doesn't know or care the difference between the wood and your knuckles, so please be careful if you're going to do this kind of thing. And here is the brass propeller shaft, the bearing, and the printed propeller. I made a spacer to hold the propeller shaft an appropriate distance away from the hull, so I have the right positioning while I make the fairing. I ground down one side of this fairing on the disc sander, and when it gets pretty close, I'll finish it up with sandpaper. The supports for the bearings are made out of wood, and they're sanded into a streamlined shape. There are 2 of these supports on each side, and they're going to be pinned into the hull and into the bearing. The rudder needs to be a little bit thicker close to the hull, so I've laminated some pieces of wood here to give it a little bit of thickness. Now I'll pin it in place and sand the hull and the rudder as if they were one piece. Now I'll cover the hull in fiberglass and leave a shell at the back where I can cut these openings out of. This feature here is called a false transom, and I'm going to do that after I've finished fiberglassing the hull. These foam blocks were made in the second video, and here I am wrapping them in saran wrap so that the fiberglass and epoxy won't stick to them. The goal is to pull the saran wrap tight so there are no wrinkles, but without being too tight that you distort the foam underneath. And since masking tape doesn't stick very well to the foam, I'm going to put another layer over top. Here's the final result on the stern. It looks nice and smooth, and it should be a good base to go over top of with the fiberglass. Here's the hull ready for the fiberglass. And this is what I'm going to use. The fiberglass and resin were bought from a local hobby shop and are usually used for covering model airplanes. The glass that I used was 0.75 ounces per square yard. That defines how thick the fiberglass is. I should have used something a little bit thicker for this project because the hull shape isn't all that complicated, and if I had used something thicker I would have been able to use less layers on the bow and stern sections where it thins out. You mix the resin and hardener in equal quantities by volume and then stir it up very, very well. The instructions suggest covering the structure with the pre-mixed epoxy and then laying the fiberglass over top. I found this method didn't work very well for me because the fiberglass cloth seemed to stick to the hull and it wouldn't lay smoothly down on the surface. I have to be honest, I was in full-on panic mode with this. The fiberglass was on and the resin was curing, so I just set up the camera and let it run. I spent a lot of time getting this to work well. The epoxy only has a 60-minute working time. But I was finally able to get all the bunches of fiberglass to lay down smoothly on the hull, and it looked pretty good. When I did the back half of the ship, I did it a little bit differently. I laid the cloth down and then poured a little bit of the resin on top. Then I'd spread it down. This way it was much easier to control the cloth because it wasn't sticking to the rest of the hull. And it's easy to tell if you've used enough resin. If it looks like the resin is soaked through the cloth, it's probably good, but if it looks dry, you need more resin. This curve towards the stern illustrates how easily the cloth forms around curved surfaces. But there are a few bumps and wrinkles in it. If you pull on the cloth at strategic points, you can get these bumps and wrinkles to smooth out nicely. As you can see, I'm not putting this layer of fiberglass over wood. It's going over earlier layers of fiberglass that has already been primed and sanded. Then I go over the whole ship carefully with a flashlight, looking for any bumps or wrinkles in the cloth or any drips of the resin. And this is the way it looks after the first layer of fiberglass is on. If you have any excess fiberglass, like I have in these areas where I've doubled up on the bow and the stern, I put several layers of fiberglass on, it's easy to clean off the loose edges by just sanding it. And you trim off the overhangs the same way. Just sand around the edges and it'll just fall off. Then I use a power sander to feather the layers into each other. Each layer of fiberglass is extremely thin, so this doesn't take long at all. Then between each layer of fiberglass, I cleaned out all the portholes. It's easier to go through one layer of fiberglass than it is to go through three after they've all cured. Before covering the entire ship in fiberglass, I made some test pieces with fiberglass covering the portholes.
I wasn't 100% sure that I'd be able to make nice portholes with this method, but it worked out pretty well. And I'd rather find out for sure on scrap pieces than on the ship itself. After removing the foam blocks from the stern, this is what I'm left with. These thin walls weren't quite as stiff as I had hoped, so I used the foam to make a paper template. And using that, I cut some thicker fiberglass to go on the inside of that shell. Then I again wrapped the foam block in saran wrap and pressed the thicker fiberglass into the inside of the shell. I used 2 layers of 3/4 ounce cloth at the bow and 4 layers at the stern, and then 1 layer of 5 ounce cloth, the heavier stuff, on the inside at both the bow and the stern. And those thicknesses seem to be just about right. As you can see, there are some voids here in the resin, but I'm going to be able to putty those and sand them and they'll disappear. I had originally planned to cut out the openings at the stern at this point, but that would have left this thin web of fiberglass that would have been very easy to break, so I'm going to wait a little bit to get more done before I do this. So that brings us to these strange little bumps at the stern. There's one behind each propeller, and they're supposed to make the ship more efficient and save fuel. I'm going to start by drawing the waterline on the model, and that will help me position them correctly. The waterline measures to be about 6 centimeters from the bottom of the hull. But it's really quite a wide band painted along the length of the ship. I'm going to estimate it at about 1 centimeter. So I'll stack some wood to an appropriate height and tape a pencil to the top of it with electrical tape. I use electrical tape because it's stretchy and it'll always be pulling tension down on the pencil. And the height of the lead is fixed at 5.5 centimeters off the table. You don't need anything expensive or high-tech for this, just stack some wood so it's the right height. You brush the lead lightly across the hull, especially at the stern where there's such a drastic undercut. Now I'll add 1 more centimeter to the block of wood so I can draw the upper extremity of that dark band. And here's the result. I'll start by tracing the stern view of this section and using that to make a small bulkhead. But it took some adjustments to that profile to get it sit properly because this surface is quite angled. Then I'll fill this space in with some blocks of wood and sand over it. I also have to make these reinforced areas where the chains and ropes would rub at the bottom of the openings. I'll use some tape to protect the painted deck and then drill a hole in the hull directly in line with the surface of the deck. And the drill bit is nothing more than a piece of steel wire with some flats cut on the end. I'll bulk up the perimeter of those openings with some wire. I'm going to make another video with some of the metal work, including soldering, but the basics are keep it clean, use a high temperature soldering iron, and use flux. I'm going to straighten the wire by pulling it until I just feel it stretch. And then equally important, not dropping it to bend when I take it out of the vise. I made a block of wood that's the height and width of the openings, and I'll form the wire around it. Then I'll use thicker wire for the bulkier area at the bottom. And it's a good idea to wash your hands well while you're doing this so you don't get skin oils onto the parts. Apply some flux to the well-cleaned parts. Clean the soldering iron tip and touch a little bit of solder onto it, and then touch that to the parts. If you use a really hot iron and you're quick enough, the solder melts and then solidifies before the heat travels down the metal to burn your hands. I use silver solder for all of my model building work. It flows really nicely, and it's a lot harder than regular tin lead solder for electronics. The reinforcements under the anchor are quite a bit heavier than any other on the ship. So I'm going to use heavier wire and then grind it down to meet the thinner wire towards the top. And this has to be done with a light touch so you don't burn your fingers or melt the solder. And here are those parts glued to the hull. I'll use a two-part epoxy putty called Milliput to fill in those spaces underneath the wire. You cut equal-sized slabs off of the two rolls in the package and then mix them together really well. Then you can use the putty as it is or thin it down with some alcohol to whatever consistency you like. I'm going to make mine pretty thin so that I can apply it with a paintbrush, and hopefully I don't have to sand too much. And to help with that, after it's applied, you can smooth it out with a finger dipped in alcohol. And I'll do the same thing with these rope ports. Now I'll use a Dremel tool to carefully carve out the center of these openings. Fiberglass is nasty stuff to breathe, so make sure you wear a respirator, and eye protection is another must-have. Now I'm going to cut off the excess material at the bow on the bulwarks above the deck. I'll use a Dremel tool with a cutoff blade and lightly run it on top of a spacer that I cut at the appropriate height. Now it's time to cut these openings at the stern. Cutting into the fiberglass I've worked so hard on is truly terrifying. So I did the lower of the two decks without the camera so I could work out the kinks. If there's no space to use the deck as a guide to cut openings, then I can use the tabletop, but the ship has to be securely mounted down and level. The rubber handle of these pliers works perfectly as adjustable leveling chocks. This wood spacer that I made will help me make a line at the top edge of the openings. Since I'm going to be cutting these openings from the outside of the hull, I'm going to drill a small hole so I can use it as a landmark. The tool I'm going to use to cut these openings is a battery-powered Dremel tool with a plastic sled that I made so I can slide it on a smooth surface. And that smooth surface is the top of this scissor lift so I can adjust the height of the cut. I'm going to make the first coarse cut at about the mid-level of this opening. I'm not taking too much care to make a really good cut because I'm going to final cut the top and the bottom in a separate cut. Then I'll incrementally move the platform up in small amounts so that I can make smoother cuts off the top. And because the decks curve up at the bow and the stern, the tabletop is not necessarily parallel to these lines, and you can see that here. So I'll raise the bow a little bit and then retighten the straps holding it down. And now I can cut right along the line. Here I'm sighting along the top edge of the upper openings to see that they're all in line. Here's a tool I made out of a scrap of wood and a pencil lead to mark the bottom edge of these openings. I simply run the edge of the wood on the top of the opening and the pencil lead does the rest. And it even works on the sharply angled surfaces at the stern. Because of the rotation of the tool, the cut is nicer in one direction than the other. So I plunge into the workpiece so that I can travel in the preferred direction. Going in the other direction, the tool tends to jump around a little bit as it tries to climb the little hill that it's cutting. Now I'll turn the Dremel tool up to its fastest setting and hand cut these vertical pieces. With the tool spinning this fast, it basically pulverizes the material, and it takes very little pressure to remove it. So you have to be very careful with this. And this is the result.
Well, it's finally come time to paint this thing. But my workshop is pretty small and it's full of dust, so I have to get a little bit creative to keep the dust out of the paint.
I'll lay a thin disposable tablecloth underneath the model when I paint it. No matter how many times I clean the bench, there's always dust that gets on the wet paint. And to keep the fumes out of the rest of the house, I've got this curtain rigged up. It doesn't seal very well, but then it really doesn't have to. I've got a fan in here to exhaust the air out of this small space, and it keeps the fumes out of the house. But I'll close the gaps if it's easy, and adding magnets to the edge of the curtain works really well with this metal drywall corner. I'll start the exhaust fan and I'm ready to paint. I put on several coats of this white primer, and I really like the color, so after putting on some clear coats at the end, this is going to be the final finish. After it's left to dry a day or two, I carefully apply the tape along the waterline, and then sight along the edge of the tape to make sure that it's perfectly straight.
This packing paper is great for masking and taping. It's lint-free and very cheap. But I had run out of this stuff, so here I'm using paper towels. Also very cheap, but not lint-free, so I had to be careful. The client and I had some discussions about the color of this stripe at the waterline. He had lots of photographs of the Oceanic and other ships from home lines, and in every picture the color looked a little bit different. He liked the look of the color on this image of the Homeric, and that's what we decided to use. It also happens to be the same color that we used on the upper decks. And here are all the colors that are going to go on the hull. The white, the red for below the waterline, the green of the waterline, and a clear coat that goes over everything. Here the first coat of the red oxide color has already been applied. As always with painting, several light coats are much better than one heavy coat. If you let too much liquid build up on the surface, it leaks underneath the tape and you'll never get a clean line. For this red color, I probably put 4 or 5 coats on. It takes a little bit of time, but it looks really good in the end, and the line is very crisp and clean. And then over top of everything goes the clear coat to give it a nice even sheen. As you can see here, I gave up on painting inside that curtain. The space is just too small and this model is too big. So the house smelled a little bit while I was painting, but I had the exhaust fan on so it wasn't too bad. I cut the panels to the crate at this time, and I'm going to attach the bottom of the crate to the model. This should help protect the model from getting bumped and scratching the fresh paint, and especially it'll help protect these fragile areas at the stern. And with this milestone, it was time to take some pictures to send the client. So I tried to photograph it inside and outside, and no matter how I tried, I couldn't get a good representation of the green. Every picture seems to be a little bit different shade, so I guess in that respect it really does mimic the original.
And that about does it for finishing the hull. In the next video, we'll be building the superstructure. You don't want to miss that.